Welcome! In this video, we'll tackle a fascinating geometry problem. By the end, you will be able to construct a triangle if you are given three key points: its circumcenter, its centroid, and one of its vertices. So, our goal is to construct a triangle given its circumcenter, centroid, and a vertex. It sounds challenging, but by using the properties of these points, we can find a step-by-step solution. To start, let's quickly review what these 3 points represent within a triangle. These definitions will be the tools we use to solve the problem. First, the circumcenter. For any triangle, this is the point where the perpendicular bisectors of all 3 sides meet. A key property is that the circumcenter is equidistant from all 3 vertices. We denote the circumcenter by O. Think of it as the center of a circle that passes through all 3 vertices of the triangle. That circle is called the circumcircle. In other words, its distance to vertex A is the same as its distance to B, and the same as its distance to C. Next, the centroid. This is the point where the 3 medians of a triangle intersect. Remember, a median connects a vertex to the midpoint of the opposite side. We'll call the centroid G. It represents the triangle's center of mass. The centroid has a special property that will be crucial for us. It always divides each median in a 2-to-1 ratio. For example, if we draw the median from vertex A to the midpoint M of side BC, the centroid G is 2/3 of the way down that median from A to M. This 2-to-1 ratio is a fundamental concept for our construction. Finally, let's briefly recall Euler's line, a beautiful result that connects these 2 points, and the third point, the orthocenter. While we won't use the orthocenter directly today, Euler's line provides a key insight into our problem. Euler's line states that in any non-equilateral triangle, the orthocenter H, the centroid G, and the circumcenter O are always collinear, meaning they lie on the same straight line. Furthermore, the centroid G always lies between the circumcenter O and the orthocenter H. We now have all the tools we need: the definition of the centroid, the definition of the circumcenter, and Euler's line. Let's see how they come together to solve our construction problem. Let's outline our construction plan. Our goal is to find the locations of the 2 missing vertices, B and C. Here's the plan. First, we'll draw the Euler line, which we know passes through the circumcenter O and the centroid G. Second, using the vertex A, we'll construct the line that forms the median from A, which we'll call the median line. The third step is to find the midpoint of side BC, which we'll call M, by finding the intersection of our median line and the Euler line. And the fourth and final step is to find the location of the missing vertices B and C. We have the vertex A, the centroid G, and the circumcenter O. This gives us enough information to begin our step-by-step construction. Let's get started. We'll begin with step 1, drawing Euler's line. On our plane, we've placed our given points, vertex A, circumcenter O, and centroid G. Based on Euler's line theorem, we know that the circumcenter O, the centroid G, and the orthocenter H are all collinear. Furthermore, the centroid G divides the segment OH in a 1-to-2 ratio. This means the centroid G is the point on the Euler line that is between O and H, and the distance from O to G is half the distance from G to H. To draw this line, we simply draw a line through the 2 given points, O and G. This line is our Euler line. There you have it. This line is the Euler line of our triangle. Next, let's consider the orthocenter H. Since G divides OH in a 1-to-2 ratio, we can find H. H must lie on this line, on the opposite side of G from O, at twice the distance. We can use a compass to find this exact point. We measure the distance between O and G and double it to find H on the line. While finding H isn't strictly necessary for our specific problem, understanding its relationship on the Euler line is an important geometric principle. Let's pause and recap. We have successfully constructed the triangle's Euler line by connecting the centroid G and the circumcenter O. This line is the foundation for finding our missing vertices. Now, let's move to step 2, drawing the median line from vertex A. We know the median line from vertex A must pass through A and the centroid G. By definition, the centroid is the point where the medians intersect. So, our task is simply to draw a line that connects the given vertex A with the given centroid G. This line segment will be part of the median AM. Let's draw that line now. This is the median line from vertex A. We know that the third vertex, C, must lie on this line because it's part of a median. The location of C is still unknown, but we're getting closer. This line is the median from A to the midpoint M of side BC. An important property of the centroid is that it divides any median in a 2-to-1 ratio. This means the centroid G is 2/3 of the way from A to M. Let's visualize this ratio. The distance from A to G is 2 parts, and the distance from G to M is 1 part. This 2-to-1 ratio is a fundamental property of the centroid. So, the total median AM has 3 parts. To find the midpoint M, we can extend the line segment AG past G by half of the length of AG. Let's do that with our compass. We measure the distance between A and G. Then, using G as our center, we use that measurement to mark a point on the line that is twice as far from A as it is from M. This gives us the location of the midpoint M. We have now located the midpoint of the triangle's missing side. Let's review. We have now found 2 crucial points. We found the location of the circumcenter O and the centroid G, and now we've located M, the midpoint of the segment BC, which is one of the sides of our triangle. This is a significant step towards our final solution. We've reached step 3 of our construction. We need to find the other 2 vertices, B and C. We know that the midpoint of BC is the point M we just found. So now our goal is to find vertices B and C. Our current situation is this. We have the midpoint M of side BC. We also know that the circumcenter O is equidistant from B and C. This means that the circumcenter O is the center of a circle that passes through B and C. This circle must have a radius equal to the distance OB and OC. Let's use our circumcenter O. The distance OA is the radius of the circumcircle that passes through A, B, and C. Since O is equidistant from all vertices, the distance OB must be the same as OA. So, let's open our compass to the distance OA. This is the radius of the circumcircle. Now, placing the compass on the midpoint M of the side BC, we'll draw a circle with the radius OA. The circumference of this circle must intersect the line that passes through M. The intersection points of this circle with the line through M are our missing vertices, B and C. Let's mark them clearly. We've found them. The points where our circle intersects the line through M are the 2 missing vertices, B and C. Notice that the circumcenter O is equidistant from A, B, and C, as it should be. We've reached our final step. All that's left is to complete the triangle. We have our 3 vertices, A, B, and C. The construction is complete. To finish, we simply connect the vertices with line segments. Connecting A to C, C to B, and B to A forms our completed triangle. And there you have it, the completed triangle ABC. This triangle satisfies the conditions of having the given centroid G and circumcenter O and passing through the given vertex A. Let's do a quick check to make sure our construction is correct. Let's find the centroid of our new triangle. We'll draw the median from B to side AC. By drawing the median from B to the midpoint of AC, we find that it passes directly through our original centroid G. This confirms that our construction is accurate. So, let's quickly review the entire process. We've gone from 3 points to a complete triangle. Here's a summary of the steps. First, we used the circumcenter O and centroid G to define the Euler line. Second, we drew the median line from vertex A through the centroid G. Third, we found the midpoint M of side BC by extending the segment AG using the 2-to-1 centroid ratio. And finally, we located the vertices B and C by finding the intersection points of a circle centered at M with radius OA. This is a beautiful example of how powerful our understanding of geometric points like the circumcenter and centroid can be. By applying their properties, we can solve complex construction problems. Today, you have learned to construct a triangle given its circumcenter, centroid, and 1 vertex. You've seen how Euler's line and the centroid's 2-to-1 ratio are key to unlocking the solution. I encourage you to try this construction yourself with different starting points. Thank you for watching.